So let's solve this problem. Cos of x upon sine of x minus a. This is from same exercise 3.2a. Second. Now this question is a very specific type of question. Now in this you notice that numerator has cos, the denominator has sine. Numerator has cos, denominator has sine. And the angle of numerator and denominator are not same. You got cos of x here, but in denominator you have angle as x minus a. There is one more question of this type, which is just after this in the textbook, the same exercise, that is third question. And the third question is integral sine of x minus a upon cos of x plus b dx. Now again, this question can also be termed as same type of question. Even this is same type of question. I classify these two questions in same type. What is that type? The type is numerator or denominator will be either cos or in sine. Like here numerator is cos, denominator is sine, and here the reverse. Here numerator is sine and denominator is cos. You can have various such problems where you have numerator and denominator are sine and cos. Now I tell you the method which we are going to apply to solve these two problems. The method would be, let me write the method here. Method here is repeat the angle of denominator, repeat the angle of denominator in numerator. That is the method. Repeat the angle of denominator in numerator. So see students how I do it. I write I equals to, the denominator angle is x minus a. So I would have to repeat it in numerator. So I have got here cos x. So cos of x, and since I want to have the same angle which I have in the denominator, so I would write here minus a, and I wrote minus a, so I will have to write plus a. Now this I am doing because I want to repeat the angle of the denominator in numerator. See, the angle of denominator is x minus a. So I repeated it, x minus a, so I repeated it, okay? And for repetition, you make a change, so you made a counter change. This plus a is because you wrote minus a, okay? So see the next step what I will write. Next step I will get cos of x minus a plus a. This is very important problem, students. So I get here cos of x minus a plus a. I will take this x minus a as one bracket and this as the second. And here sine of x minus a. Now the numerator, I shall be treating it as, I will treat this numerator as cos of a plus b. You all know, students, what is cos of a plus b. Cos of a plus b, I will write cos a cos b minus sin a sin b. Cos a plus b is cos a cos b minus sin a sin b, and here you have sin of x minus a. cos of a plus b, a, and this is my b. So cos x minus a cos a minus sin x minus a sin a, and then this. After this, what I do, students, I will split the denominator. So I will get I equals to, separately dividing, so I will get I equals to cos x minus a cos a divided by sin x minus a minus sin x minus a sin a divided by sin x minus a dx. Okay. Next, this sin x minus a cancels, and here you get, for this you get cos x minus a upon sin x minus a, you get cot x minus a, cot x minus a. So you get I equals to cos a cot x minus a minus sin a dx. So I write separate integral, integral of cos a cot x minus a dx minus integral sin a dx. So here you have cos a being a constant, you write it out, and integral cot x minus a dx minus sin a is out, you have 1 dx. So now you all know integration of cot x. Integration of cot x is log of sin x. So this becomes cos a, and here log of sin x minus a, cos a into log of sin x minus a minus sin a into x plus c. This is final answer. This is final answer. So let's solve one more problem, students. As I told you that this question, this one is same as the previous type. What was the type? The type was we will have numerator and denominator either in sine or cos, and the angle would be different. And what is the method? Method I have already written. The method is repeat the angle of denominator in numerator. That is the method. So here once again I will try repeating the angle of denominator in numerator. So see, what do I do? I write the denominator is cos of x plus b and the numerator is sine of x minus a. I want x plus b. As I told you, the method is repeat the angle of denominator in numerator. So x is there, I wrote x, then I write plus b. I write here plus b. Now why write plus b? Because I have in denominator plus b. If you wrote plus b, you will have to write minus b. Okay, and then minus a is already there. So you got x plus b minus a and dx. Next step. So you have sine of, now x plus b I write in one bracket, then I take negative common, I get a plus b in another bracket. Okay, and here I have cos of x plus b. So the numerator now becomes, what is numerator now? The numerator is sine of, it is in the form sine of a minus b. See, it is in the form sine of a minus b. So I shall apply the compound angle formula sine a cos b minus cos a sine b. Okay, so here I write the formula sine x plus b, sine a cos b, cos a plus b minus cos x plus b sine a plus b. and the whole thing divided by sin A cos B cos A sin B, and this whole thing divided by cos of x plus b, and then dx. Very important problem. So the next step is, alright, therefore I equals to, now the denominator I would split. So in the numerator I have got two terms. One is this, okay, and the other is this. I will split the denominator. So I get here sine x plus b cos a plus b upon cos x plus b, and minus cos x plus b sine a plus b divide by cos x plus b. So here cos x plus b cancels, and here you get sine x plus b upon cos x plus b will get you tan of x plus b. So I get here integral tan x plus b minus sine of a plus b dx. So I'll now write separate integral. So integral tan of x plus b dx minus integral sine of a plus b dx. Okay, now, okay, so with this cos a plus b is also there, which I missed. So I will rectify that. Mistake realized is no mistake, as you know the saying. So here what do I have? I have tan x plus b into cos of a plus b. I had forgotten to write this dx. Okay, integral this, I wrote integral this minus integral of this, integral sine of a plus b dx. Okay, so next step. Now here in the first integral, you notice that you got two terms, cos a plus b. This is constant. There is no x in it, which is multiplied. So this will go out. So you have here cos a plus b integral tan of x plus b dx. Tan of x plus b dx minus, here you have sine of a plus b, sine of a plus b, which is a constant. So it will come out here sine of a plus b into 1 dx. So you have I equals to cos a plus b, and you know students, what is integration of tan x? Integration of tan x is log of sine x. So this is log of sine x plus b. Integration of tan x is log sine x. So log sine x plus b minus sine of a plus b, and integration of 1 dx is x plus c. This is final answer. Very important, very simple question. You should all practice this again and again. Thank you. Yeah, here I made a mistake here, students. This is integral tan of x plus b, and integration of tan x dx is log of sec x plus c. So here it should have been sec, not sine. Here it should have been sec and not sine. So I will change this. I write it sec of x plus b. Integration of tan x plus b is log sec x plus b. This is final answer. So we have integrated two very important problems. These two problems, this problem as well as the previous one, these two problems fall under one type. And what was the method? The method is, how do I recognize this type, students? Very simple. In numerator, I will have cos, denominator sine, or reverse. I will have numerator sine and denominator cos. The angles would not be same, but they can be made same by some adjustments. So here the method was same, that I will try to repeat the angle of denominator in numerator, and that's what I did by adding, subtracting constants. You have two methods, you have two problems before you. So now we go ahead and check. Yeah, here one more thing I would like to say, students, that see, we do not have division rule in integration. What we have is only transformation, which will lead us to a step. See, I did not find this in the list which I have, the list of the results which I have. I don't find this. So what I did, I made some transformations. Okay, this is what is going on. What is this all happening? This is nothing but transformation taking place. Okay, this is all transformation taking place. I'm trying to transform the given function into a form where I could integrate. And see, students, I brought it into a form where I could apply the result. The moment I got such a form where I could apply the result, I applied it and it is over. So jokingly, some people say then that in an integration problem, there is only 5% of integration happening. Rest all is trigonometry or any other thing which we are coming across. See, you can check. The actual integration is taking place only at this place. See here. That's why jokingly people say that in any integration problem, the integration is only 10%. And what is 90%? 90% is manipulation and transformation. 90% is manipulation and transformation. So be it, nothing you can do, nothing I can do. The way it is, it will be treated that way only. Now let's move to the next question. See, students, the next question which I solve is number 13. Okay, so 13th is, let I equals to integral tan of 3x into tan of 2x into tan of x. I have to integrate this. Remember, students, derivative is considered to be much easier topic than integration. The reason being, derivative is full of rules. You have so many rules: addition rule, subtraction rule, multiplication rule, division rule, composite function rule, parametric function rule, inverse function rule. So many different rules you have there. But in integration, you hardly have rules. Here you have got only, if you have integral of f of x plus g of x dx, then you can write integral f of x plus integral g of x. That's it. You have integration of f of x minus g of x dx, then you can write integral f of x minus g of x. If you have integral k f of x dx, where k is a constant, then the only thing that you can do is k is out and integral f of x dx. Other than this, you cannot do anything. You cannot do anything. These are the rules available. Okay, very good. So here I have got tan 3x multiplied to tan 2x multiplied to tan x. What do? I don't integrate this. No, we will integrate, but we will apply the transformation method. For this, I would transform it in such a way that I get something which I could integrate. So I will write here. See, how do I write? We can write tan of 3x equals to tan of x plus 2x. And students, you know x plus 2x is 3x. So this will become tan of a plus b, tan a plus tan b upon 1 minus tan a into tan b. So tan x plus tan 2x upon 1 minus tan x into tan 2x. And here you have tan of 3x. Now I cross multiply. So I get here tan of 3x 1 minus tan of x into tan 2x equals to tan x plus tan 2x. This is what I get. Okay. So this tan 3x would multiply inside the bracket. And what does it get you? Then it gets you tan 3x into 1 minus tan x into tan 2x into tan 3x equals to tan x plus tan 2x. And what is next step, students? Now this term, which is product of tan x, tan 2x, tan 3x, I will shift to right, and these two I shift to left. Okay, so see students, what do I get? It will get me now. So I get here tan of 3x minus tan of x minus tan of 2x equals to tan x into tan 2x into tan 3x. So see, I got here something. I got here something which is the integrand. See, tan x, tan 2x, tan 3x. I got the same thing here. Tan x, tan 2x, tan 3x. So what would I do now, students? I got this as equal to this thing. So my integral will become, therefore I equals to, instead of integrating this, now we would be integrating this because this is equal to this. So next step I write here I equals to tan 3x tan 2x into tan x, which is equal to tan of 3x minus tan of x minus tan of 2x dx. Now I write separate integral. So integral I equals to integral tan 3x dx minus integral tan of x dx minus integral tan of 2x dx. Integration of tan of 3x is log of sec 3x. What is integral tan x? What is integral tan x dx? It is log of sec x. So if you now tell me, sir, this is not tan, here we have tan x dx, but this is not tan x, it is tan 3x. No worries. Why no worries? Because I would say x is replaced by linear algebraic in x. Ax plus b, see here, a is 3, b is 0. Okay, so I can apply this. So what would I get? Integration of tan 3x, I will get log of sec 3x, log of sec 3x, the whole upon 3. Some students make mistake of writing only 3x upon 3 or sec 3x upon 3. No, it is the whole thing upon 3. Minus this is log of sec x. It is simply tan of x, only no need to write divide. See here, this is tan of x, so x coefficient is 1. Even if you divide, it would be just division by 1, which is same. Minus log of sec 2x, the whole divide by 2 plus c. This is answer. This is the final answer. So if you want, you can write this as, I think that's it. This is it. No need to go ahead. This is where we stop. This is the final answer. Students, it is time now I teach you how to solve problems, how to integrate few integral using the method of substitution. So till now, all those problems we have solved about 13, 14 problems. 13 to 14 problems we have solved. And in these 13 to 14 problems, if I wanted, I could have used the theory of substitution. Theory of substitution could have been used even for these 13 to 14 problems. But we did not use theory of substitution for these questions. What did we do then? We used the corollaries which are originating from these theorems, this main theorem, okay, from this theory. So we used these theories, these results, these theorems, these sub theories, these corollaries to solve these 13 to 14 problems. But when I say these theories, what do I mean by these theories? It is f dash x upon f of x dx. It is f dash x upon root of f of x dx, and it is f of x raised to n into f dash x dx. So what I'm trying to say is all those problems which we solved using these theories could have been easily solved by this theorem of substitution, which is main theorem. But we did not make use of this method because we wanted to solve only those problems using this theorem which cannot be solved by these alone. Okay, so which are simple questions and which can easily be solved by these theorems. Why use this theory for them? So let's begin and solve some problems. So here I will begin with some few easier questions, and then I shall take the discussion ahead. So the first one I have here is, okay, so let me give the heading integration by method of substitution, by method of substitution. Okay, so as the name suggests here, students, in this method we are going to use substitution. So I will begin. So here I take few examples. So let's take the first example I take is example 1. I take example 1. Suppose I have to integrate cot of log x. I have to integrate cot of log x upon x dx. Okay, cot of log x upon x dx. So I want you all to be very attentive. See here, I have to integrate this. So this is my integrand. This is my integrand. Okay, yeah. Now here when I see cot of log x dx, what is it which amazed you? See, something that really amazed me is the angle of cot. See, it is cot of log x. Cot of log x. Okay, fine. So why did it amazed me? Because it amazed me because I am not happy with it. I am not happy with it. This is something which is, I can say it is bad. It is bad. Why it is bad? Because I am not liking it. Why I am not liking it? What do you like in that case? I would like cot x dx. I would like this. I do not want cot of log x. I want cot x dx. Why so? Why do you want this? Because if I have cot x dx, then I will write the answer by using my theory, by using my results, which I have already done. I have written in the list. Cot x dx would be log of sine x plus c. Okay, so if it is this which you like, and what is it which is not making you, what is it which is not letting you use this result? What is it which is not letting you use this result? Very simple. It is this log x. It is this log x which is not letting me use the result. Okay, fine. So you know, students, this log x, I will call it as bad angle. Okay, I repeat that. I call it as bad angle. Bad angle. It is angle, but it is bad angle. Why bad angle? Because I wanted, I thought it to be, I wanted it to be x. See, I wanted it to be x. Why x? Because here it is dx. Cot x dx, cot x dx. If it is x, I wanted the angle to be x. It is not x, it is other than x. It is bad angle. And remember, students, whenever you have some bad angle, you will put that as t. You will substitute that. You will make that bad angle a good angle. How do you make it good angle? You will all now notice. So see here, I will write put log x equals to t. Put log x equals to t. Remember students, after you have made a substitution, the next step you will do is differentiation. Differentiation. Why differentiate? You will know it. Just give me a minute. I will now write differentiating with respect to t. Okay, you can also differentiate with respect to x if you want. So log of x as t. So when you differentiate, or you could differentiate with respect to x, either of them is okay. So here what you get students, you get d by dx of log x equals to d by dx of t. What is d by dx of log x? 1 upon x, and here you have dt by dx. So this dx I multiply onto left hand side, so it will become 1 upon x dx equals to dt. 1 upon x dx is dt. Okay, so students, let's have a quick revision of what we did so far. Let's have a quick revision. I saw a bad angle, I put that bad angle as t. This is my substitution. Okay, this is first major point which you need to understand. The second one, what I said, the moment I substitute something as t, the next step is I differentiate. Okay, now I will tell you why we need to differentiate that immediately. Listen, my dear students, this is cot log x, this is upon x, and you have dx. If you are thinking of removing log x and writing t there, if you are thinking of removing log x and writing t there, wouldn't it become cot t? Cot t, remember, and if it becomes cot t, it would be a function of t. So if it is function of t, this dx will not help us anymore. We want dt with respect to t we want. That's why I did so. Okay, now I hope you have understood. So students, after doing this much, see what I do. I now write the new integral after substitution. So the new integral will be I equal to cot t. Cot t. See, it was cot log x. Cot t. Okay. What more? And see this. 1 upon x dx is dt. And here you have 1 upon x dx. 1 upon x dx is same as dx upon x. And see this. Dx upon x. Dx upon x. So this whole thing, what I will write, see, you got cot t, and this thing is dt. So what you have now, you have now cot t dt. What is integration of cot t dt? What was integration of cot x dx? It was log of sine x. So cot t dt will be log of mod of sine t plus c. And now I resubstitute t. T was log x. So it is log of sine of log x, log of sine of log x plus c. This is the final answer which we have. So this is how you solve a problem using substitution method of substitution. Again, rewind the problem and once again listen to this. Very important. This is first example. We are going to have many more for such examples. So students, let's take one more question where we will use the method of integration by substitution. So example number 2. Let's take one more question. I have here, let I equals to e raised to x into 1 plus x divided by cos of x into e raised to x dx. So students, if you ask me to go for this question like a beginner, then see what should be my steps. Step one. Step one, I will first see this and think whether it is in the list, any result. List any result. Is any result applicable from the list? The answer is no. I do not have any result working on this. Okay. Then I will think of some transformation. Is any transformation working on this? Like if you remember, we separate the denominator and all that. See, no, I'm not getting any such idea. Okay, but while talking about this question, suddenly I see something which is very much surprising. What is it? Cos of x into e raised to x. See here, cos of x into e raised to x. This is angle for cos. I am integrating with respect to x, but this is not x. Is this cos of x? Is this cos of x? No, it is cos of x into e raised to x. So this thing I will term it as bad angle. Remember students, I will call it as bad angle. And as I told you in the previous question also, when we see bad angle, we put that bad angle as T. We substitute bad angle as T. So the same thing I did here, we put bad angle as T. Okay, this is my first thing. Okay, now this is my substitution, bad angle as T. So I'm going to write here, put x into e raised to x equals to T. This is what I will do. Remember students, when I say I'm putting x into e raised to x as T, look at this. It is not the whole denominator. Is this the denominator? No. If you check the whole denominator, then it is cos of x into e raised to x. It is just a part of denominator. It is the angle of cos which is in denominator. So remember students that when you are making use of substitution, there is no hard and fast rule that which part of the integrand will be substituted as T. There is no such hard and fast rule. It could be the whole numerator, sometimes it could be the whole denominator, sometimes it could be some part of the denominator like here, sometimes it could be some part of the numerator, it could be in the power, it could be inside the square root, it could be anywhere. Right now, as we will proceed students ahead, you will know slowly and slowly as the things will unfold, you will get more and more ideas. Right now you have learned only bad angle. Okay, if I see bad angle, I will put bad angle as T. And how does that, but then once again, but just putting bad angle as T, how does it help me? Oh dear, why wouldn't it help you? Check. If it was cos of, check, if it was cos of x, if it was not cos of this, it was cos of x, what it would have been? It would have been sec x dx, and I would have applied the integration log of sec x plus tan x plus c. So here, what is it which is not letting me apply my result? What is it? What is it which is not letting me apply my result? Very simple. It is nothing but this. It is this which is not letting me apply my result. This bad angle. And this bad angle is troubling us. So I will make this bad angle a good angle. I will make this bad angle a good angle. And how do I make it? By substitution. So I put this thing as T. Don't put this thing as X. You can't do it because you already have everything in X. So how could you put X into e raised to X as X? That is not done. You will put this as some other variable. Okay. Then I told you students in the previous problem, the moment you put this as T, the next step you do is you differentiate that with respect to X. So I will write differentiating with respect to x. So you have therefore d by dx of x into e raised to x is d by dx of t. Now you apply product rule, u into v rule. So you have x, d by dx of e raised to x is e raised to x plus e raised to x, d by dx of x is 1. The derivative is over. Then the next step, see here students, you check this dx here, this will go in numerator, it is dx, and here you have dt. So now I take e raised to x common, so e raised to x is common, you get x plus 1 dx equals to dt. Okay, so see how it is helping you. The things will now change and it will get you something where you can apply the result. Okay, having done this, now check what is happening. Here you have e raised to x dx, which is equal to dt you are getting. Okay, and here also you have e raised to x dx equals to dt. Okay, so now I will write the new integral after the substitution. So I equals to, I will get I equals to integral, the numerator is dt and the denominator, see the whole numerator is dt, the whole numerator is dt and the denominator is cos of t. So the next step, it is 1 upon cos t dt, so it is sec t dt. Integration of sec t is, what is integration of sec x dx? It is log of sec x. Integration of sec x dx is log of sec x plus tan x plus c. It is log of sec t dt. So this will be log of sec t plus tan t plus c. And what is t here? T is, I will resubstitute. So log of sec e raised to x into x, sec x into e raised to x plus tan x into e raised to x plus c. This is I. This is my final answer. Okay, this is done. Yeah, this is over. We have integrated it. Okay. Now here I would like to say something more, add some more pointers to this. So here, what were the, okay, let me write those pointers which I'm making. See, point number 1, some important pointers I'm going to make here. So here I write point number 1. See, point number 1, the substitution can be anywhere. Substitution can be from any part of the integrand, can be from any part of the integrand. That means, see here it is, here it is an angle in the denominator, but the previous one was angle in the numerator. Okay, second pointer was, after substitution we will differentiate immediately. Why differentiate immediately? Why differentiate immediately, students? Because we need to change the differential. We need to change the differential, that is from dx to dt. From dx to dt we need to change the differential. Dx will go and dt will come. Okay, 2 pointers. Okay, then the third pointer, I will write the third pointer here. Let me write the third pointer here. See, the third pointer which I am writing, it is something which will happen 95% of the times. It will happen 95% of the times. Okay, you may even increase that percentage, but few problems it may not happen. Few problems it may not happen. So see, the third is after differentiation. See, what was the second one? After substitution, we will differentiate immediately. Yes. So after differentiation, that is after you will have differentiated, after differentiation, we get something to resubstitute, back in the integral. We get something to resubstitute back in the integral. Now what does that mean? I will tell you. See here, when you substituted this as a t and you differentiated, you got this thing which was here. You see this? It was here. That is what I said in the third pointer, that after differentiation, we get something to resubstitute back in the integral. So see, this thing which I got as a dt, I already notice it here. So I'm getting this to resubstitute back. So see what is happening. The whole integral problem changes into a new variable t. See, cos t, and this whole thing is dt. Cos of t in the denominator, cos of t, and the numerator, the whole thing becomes a dt because I'm getting something to resubstitute back. Think if such a thing would not have happened, it would have actually made the problem difficult. Why? Because if something like this not happening, which happened here, then I would get cos of t, but this would all remain in x. That is not correct. How could you have in one single question two variables with a single differential? It is very important that you end up with everything in t. Okay, so when you write, like, see, when you had dx, wasn't this all in x? This all was in x. Yes, it was completely in x. So when you have dt, it should all be in t. That is very important. I hope you all have understood. Again, play the video again and again and listen to it, make a note of it. Okay, thank you. Okay, let's see some more problems of the similar type. So here I have one more question. This is exercise 3.2. One third. Let I equals to, I have a problem here in which I have numerator as 1 plus x and denominator is x into sine of x plus log x. Okay, so this, students, this will be for you all. This you will all practice. Once again, what you notice this bad angle, sine of x plus log x. You will put x plus log x as t and then you work on this. Okay, you follow everything which I did in the previous question. So when you put, see, when you will put x as x plus log x as t, when you will put x plus log x as t, the next step you will differentiate with respect to x. Okay, remember, when you will differentiate with respect to x, you will end up with something here, and that's something which you will end up with something dx equals to dt, that will lead to take this whole thing away. that is 1 plus x upon x dx. It will lead to take this whole thing away, and you will get everything. The new integral that you will write, it will be dt here, and this whole thing will have converted as a function of t. You will have dt and whole thing will have converted as function of t. So this is homework for you. You will definitely do it. Okay. Then next I take for you, the next question I take is number 11. I take number 11. See, the 11th question is, let I equals to x raised to 9 into sec square x raised to 10 dx. Okay. Now, once again, what I notice here, I notice this angle with which I'm not happy. This is bad angle. Why you are not happy with it? Because I want, if I had sec square x dx, if I had sec square x dx, then it would have been tan x plus c, but it is not sec square x. What is it which is not letting me use the result? It is this x raised to 10, because of which I'm not able to use the result. So what I will do, I will put this bad angle as t. Okay. And when, then see, you might be thinking that you are talking about bad angle, but why are you not talking about this x raised to 9 here? X raised to 9. Don't worry about this. When you will go for converting this into a good angle, it would be taken away with dx. How would it be taken away? Because when you will put x raised to 10 as t, you will differentiate with respect to x. So this will be d by dx of x raised to 10, and here d by dx of t. D by dx of t, derivative of x raised to 10 with respect to x is 10 x raised to 10 minus 1, 9, 10x raised to 9 equals to dt by dx. So you will have here x raised to 9, multiply dx here, dx equals to, take this 10 down here, dt by 10. So see, the new integral will become, what will it become? It will become I equals to, this thing will be, this x raised to 9 dx is dt upon 10, and what is this, sec square t. So this is your new integral. The next step, you will write 1 upon 10 out, because it's a constant, and sec square t dt, integration of sec square t is tan t plus c. Integral sec square x dx is tan x plus c, it is sec square t dt, tan t plus c, and that is over. You will complete this as well. Okay. So you can repeat these problems again and again and do them. Thank you.